All right, so let's take a look at 67. This is chapter 4. And I'm going to draw that picture. We got a 422 and a 185 block. So am I getting the right picture? Is this the right one, guys? Yeah. Yep, okay, so 185. Oh, and this is a good time for you to mention, if someone says something's a 35 Newton desk, they've given you the weight of the desk. If they, that's not a very good number for a weight of a desk though. So a 35 Newton object, that's the weight of the object. If they say a 3.5 kilogram object, they have not given you the weight, they've given you what? The mass. Look at the units. Even if they say the object weighs 3.5 kilograms, they still didn't give you the weight. What did they give you? The mass. Be smarter or more aware than the person that wrote the question of that. Okay? So this is our setup, and there's a couple different ways to do these problems, and there's really only one way you guys can do it right now, and that is to treat this as an object, draw a free body diagram, treat this as its own object, and draw a free body diagram. So I'm going to do that way first, and then show you the shortcut. I'll have everybody tune back in when I get to the shortcut, because none of you, did Mr. Lindsay teach you a shortcut on these problems in regular physics? Did you even do these problems in regular physics?
I think we did.
You did them?
Yes,
did he teach you a shortcut or not? Probably not, right? Thank you.
I remember specifically doing these like at right angle, massless, frictionless.
Yeah, you did some of these. So he may have shown you the, is this you or is this the other? Okay, all right. I don't have all the last names down there. All right. So if you know the trick, still tune in so you can see my version of it just to make sure it's the same. So I'm going to draw a free body diagram for this guy right here, and I'm going to abbreviate. You guys should still be doing what? At least in this assignment. Force of blank on blank. Yep, force of something on something. But I'm going to abbreviate up here. You will get to abbreviate probably as soon as we get to chapter 5. Okay? So I'm going to write the normal force going up and the force of the weight. And I'm going to call this, just for notation's sake, block 1, block 2. Are you all right with me calling block 1 and block 2? Yes? Okay. So this will be weight 1, because I want to keep that straight because I have more than one weight. Okay? And so that's the ground, or the surface pushing on the block up. Got the weight pulling down, and then one other force. There's a rope here attached to this. Ropes cannot push. If a rope pushed, it gets slack, and then it can't do it. Okay, ropes can only pull. So this rope attached here is pulling to the right. So I'm going to call that force of the tension. I'll just call it F sub T. Are you all right with my notation?
Yeah.
Okay. And for this one, because most of you did it this way, we could avoid a little bit of the algebra if we were a little bit clever in how we did this. I'm not going to do that. I'm going to do it the way that most of you probably attempted it to show how it worked that way. For this one, I'm going to use the standard for both of these, up and right positive. So up and right's positive for both of these. I'm not going to play around with which way is positive as I do this. Okay. Now, so that's for block 1. So this is for block 1. Now I'm going to draw a free body diagram for block 2. Block 2 is a lot simpler. Oh, and was friction neglected in this problem?
Yeah.
It said neglect friction or something like that. It said smooth surface. It says
frictional effects. Assume the pulleys to be massless.
yeah. So massless pulleys, massless ropes, frictionless surfaces. Sometimes a good approximation, sometimes not, but oftentimes they'll do that in physics. They'll say massless ropes and frictionless surfaces, but not always. We'll have problems like this that will have friction. Okay. So for block 2, so that was it for block 1. For block 2, we'll have tension going up, the force of tension of the rope going up, and the weight of block 2 going down. Before I go any further, anybody have questions on my free body diagrams? And I'm not trying to draw the arrows to scale or anything like that. Questions on the free body diagrams? Because if you don't understand this, the stuff I do next is kind of pointless. I should probably flip this around just so I can tell that I'm recording. That might be nice. Yeah, it's recording. Okay. It shifted though. It's all goalie-wumpus. So I'm going to go ahead and sum forces now. And what are we trying to find? They probably asked us to find something, right? Acceleration and tension. So we're looking for, I'm trying to find acceleration. I'm trying to find the force of tension. These are the two things I'm trying to get. So I'm going to start summing forces because I'm looking for a force and I'm looking for an acceleration. So let's start here with block 2 just because it's simpler. And let's sum the forces in the y direction. And this for block 2 equals the mass of block 2 times the acceleration of block 2. Two forces, solve tension minus the weight of block 2 equals the mass of block 2 times the acceleration of block 2. Are you all right with that from the summation step, from the free body diagram? I'm checking in with you. Are you okay with that?
Yeah.
All right. Now, I know the weight of block 2. And if you know the weight of something and you know you're near the surface of the Earth, can you also find the mass of that object?
Yeah.
Yes? Okay. So there's some scratch work over here, just off to the side. I'm going to put that 185 newtons equals m times 9.8. So instead of multiplying by 9.8 like we normally do to get our down arrows, this time we're dividing by 9.8. Let me grab my calculator so we can do this relatively efficiently. 185 divided by 9.8 should be about, 18.9. That sounds good. 18.9 kilograms. Are you okay with this thing that I did over here? So I got the mass. And you'll never have negative mass. Okay? Never have negative mass. How about kilograms? So 18.9 kilograms. So I know M2, I know weight 2, but I've got 2 unknowns and how many equations? 2 unknowns? Okay, this is just scratch work. How many equations do I have and how many unknowns? 2 unknowns, 1 equation. Can I solve? No, I'm stuck. So now what am I going to do? Keep going. This is the problem-solving process if you don't see what to do. So I've summed the forces on this one and I'm stuck. What could I do next? Sum the forces on the other one. You could say sum the forces here in the x, but there's nothing going on. So which direction am I going to sum the forces here, the y or the x? Well, since I'm looking to have tension as one of my variables, I might want that to be in my other equation. So I'm going to go ahead and pick wisely and sum the forces in the x direction. Is that okay? So this will be for, this was for block 2. Now I'm going to put it over here. This will be for block 1. So summation force in the x direction for block 1, M1A1, and it's just tension. Force of tension equals M1A1. If I had friction in this problem, like they gave me a coefficient of friction, I probably would also have to sum the forces in the y on this block. But with no friction, I don't actually think I need that. Okay? I don't think I'm going to be needing to sum the force in the y direction. You still draw the forces on your free body diagram. Okay? So now we're getting a little bit better. I got another equation, but oh, bad news. I added another variable. Okay, actually 2 variables right now. Let me get M1 so we can get rid of one of them. So this will be 422 newtons equals M. This was M2. M1 times 9.8. And let's take the 422, divide by the 9.8. Be like 43. That sounds good. 43 kilograms. Is this still okay over here? This little bit of scratch work just to get the masses? And I'm calling it scratch work because it's not something that you always do. It's not this big formal process. I would be okay if you even just did this in your head. On an AP question, if part A says find the mass and they show the weight or something like that, you probably would want to give a little bit of work. But in general, this is something that I'd be okay if you just didn't show it, okay? If you're comfortable with those things. Okay. So now we know M1, but we have these 2 unknowns. So we've got a total up here now of 3 unknowns and how many equations? 2. So we're still stuck. So we need something else. So we have to look at the problem and think. Here's the thinking part. Okay. And let me make sure I'm consistent with my signs before I go any further. Right was positive, up was positive. So yeah, this is all okay. All right. Block 2 and block 1 are connected. If this block, let's say, accelerated down at 3 meters per second squared, what would this block do? Anybody? Accelerate to the right at 3 meters per second squared. They're going to move together because they're connected by a rope. How many people are okay with that? They're going to move together. Okay? It's like me holding on to this pen. If I start running across the room and my acceleration is 5, this pen's acceleration would be 5 because we're connected. So the magnitudes of these 2 accelerations will be the same. But now what about their directions? When block 2 goes down, block 1 goes to the right. So I want to turn that now into a way to relate A1 to A2. So we already know that A1 and A2 are the same size. How do I account for that difference in direction? Because one's going to go to the right, which is positive, and one's going to go down, which is negative. Let me make up a number. This is problem solving again. If this was 3 meters per second squared, positive, because it's going to the right, what would the acceleration for this object be? Negative 3. So just throw a negative on either side. Is that okay? Because now it works. You can put one in and get the other. Or A2 equals negative A1. These are algebraically the same. Whichever one clicks in your brain better. They are the same thing. Is that okay? Questions on this idea before I move on? And if stuff's in the way, because we haven't been using the whiteboard a lot, please tell me. I'll get it out of the way. Everybody else is okay with this that's watching right now? It's a problem solving thing. Okay, now we got good news, because I can just replace one of these with the negative of the other. And then I'll have 2 equations, 2 unknowns, and then algebra 1, algebra 2, whatever takes over. So which one I want to do, I want to make this as easy as possible. I think I want to I don't know which way is easier. It doesn't matter. I'm going to put in for A2, I'm going to go ahead and just put it in right here as a negative A1. Is that okay with you? I could have done either way. And now we can solve. All right, I'm going to put the process up here. I'm going to rewrite this slightly. Everybody look right here if you're watching right now. I'm going to take this negative and just move it out front. Is everybody okay? I'm going to rewrite that too. Is everybody okay with what I just did there? That's just going to make my life easier when I start doing the next step. I'm going to solve. I will put the work up here, but if you think you know what you're doing, go ahead and solve. But I'm going to go ahead and solve it up here and then go over it at the end. And there's a bunch of substitution now. I just got to be careful. Oh, and tension, we didn't have to worry about that because tension, up was positive, right was positive. They were already lined up. Okay. So tension minus 0.2 is 185. One of my equations, and you can solve solve system equations however you want. I think I'm pretty sure I'm going to solve this one for tension, and then plug in over there. I think that's what I'm going to do. Yeah, minus. So tension will equal M1. M1 is 43. Yeah, maybe I better put one more line. So I'll put something stupid. 43 plus 2.9. Oh, the acceleration of this problem is 3. I was just making up a number. I happened to pick the number of the problem. I'm sorry. I wasn't doing that intentionally. Is it actually 3? Yeah? Okay. That was dumb luck, guys. I wasn't, or maybe I looked at it earlier. No, I didn't look at it earlier. So no, just dumb luck. I'm not that good. I cannot look at a problem like this and just go 3. Now I could, if you forced me, I could do the shortcut way and get to the answer, but it wouldn't just be a glance. I'd have to do some mental math. A1 is 3. So now tension. Oh, let's see if that makes sense. A1 to the right. Yeah, 3. So 120. Oh boy, this is so sad. 129. Yes. Okay. Give you guys about 3 more minutes to try to finish the algebra if you're doing your own, and then we will we'll discuss the result here. So if you're watching this at home, fast forward. I need some more caffeine for sure. I just did, what was it? Somebody may have told me. I just did 43 times 3 on my calculator. Did you get it to work out? Yeah. Did you also solve for the tension after you got the acceleration? Let's say I think I prefer being at the whiteboard, but I don't know that it's better. I'll compare the videos and see. So, take a picture of this. Post-its that are on there. Everybody still working on algebra on this one that needs more time? Cut it a little short if not. Everybody still working on this one right now? You guys are all doing something else. Okay, so at the end of this, you should tune back in. Tune back in. At the end of this, you should check your answer. How do you check your answer? Well, with no friction, okay? Block 2 is certainly going to make block 1 accelerate to the right. Does that make sense? This is hanging off a cliff. So we should get a positive answer for acceleration. Did we get a positive answer for acceleration? Yeah, it worked out that way. Although I did put the signs on already. No, I didn't. I never considered what the sign was for this variable. So it should work. Since I didn't ever think about that, put a plus or minus on there, I just left it alone, I should get the correct sign then. And we are getting the correct sign. And then after you have that acceleration, you come back in, you plug it into the simpler equation, would be my advice, and solve for tension of 129 newtons. This is go ahead, yep.
It says find the acceleration of the 2 blocks, so it wouldn't be plus or minus 3.
Yes, with the way we just did it. A1 would be 3, A2 would be -3, and the tension for both would be 129. Yeah. Or you could say both blocks have a magnitude and acceleration of 3. Here, in a shortcut way, it would not matter, because they're both going to be the same answer. I'll explain in a minute.
Isn't there a symbol for magnitude?
Absolute
like
value. Absolute value if you mean the magnitude of something. Yep. All right. Now, what was the other thing I was going to say here about this? Oh, tension. This is a good time for me to mention. I sent out a link in case you haven't figured this out about tension. Everybody tune back in. Everybody tune back in briefly. Tune back in because you're all going to have to tune back in here in a minute. So if you're reading something else, close it up. Close it up if you're reading something else because you're going to need the shortcut here in just a second. But I'll have everybody tune in here first for this. Don't work on anything else right now. Tune in. Tension, same magnitude everywhere. For the ideal ropes that we're dealing with, tension will be the same everywhere in the rope. Its magnitude, it can just change direction if it goes around a corner. So in other words, if you have 50 newtons here, and it's the same rope, there has to be 50 newtons here. We're okay with that idea. All right, the idea. If you want more than that, I sent a link out a couple days ago where you can read and then watch a video, and if you need more. But don't overthink ropes. And ropes can only pull. Now, this is the long way. If this way makes sense to you, great. You will have time on test day to do it the long way. But if I can show you a way that cuts this down to about half as long, and it makes sense, which way should you use on test day? The shorter one, right? So you can spend more time on something else. And the short way gets even more important the more complicated this problem gets. For example, you will have problems like this, like that. All of a sudden you do that, the shortcut method becomes even more to your advantage than it does with this one. Okay? Because the work's getting longer and longer, more likely to make a mistake. In fact, problems like this, look at all this work. Problems like this, even in throwing in friction here, can be multiple choice questions. Multiple choice question, and this long way, if you did all of the steps, it would take you maybe 5 to 10 minutes if you've done one of these before. Okay, shortcut way will take you a matter of 2-3 minutes once you practice it some. And I will make you try the shortcut way several times. But if by like the 3rd or 4th time you can't do the shortcut way, forget it and just do it the long way. Okay, so if I get any questions on the long way before I go to the shortcut, because the shortcut's weird. It's valid, but it's weird. All right, so I'm going to get rid of all of this. We're going to keep our picture. I'm going to temporarily keep those free body diagrams. And here's the shortcut. I think I'd like to make this a new video. So let me come around here and stop recording.